Okay, let's go through from chapter 2. We'll go through it kind of quickly, move through 3 and maybe 4. So this is chapter 2 is about vectors. And how do we create a vector? We use the combine function, right? And so if we do this, you can do this, by the way. If you've already done the homework, you have the problem, you can just click there. It allows you to do it again. So you just type in that, and you get a vector 4, 7, 9. Okay, and then we did this one. What's the difference between this? What's the difference between this one and this one? In fact, here, try this. Try putting this into R. Copy that and put it into R. And I'm sorry, give it a name. Call this one A. And by the way, you can use the equal sign instead of the arrow operator if you want. Okay, so you can do that. And now I check A, and I see I have that. Now do this, the other one, do B, call it B. So this one, call it B. Sorry, B. Okay, like that. And then check B, see what's in B. Oops, what happened? Oh, I tapped C. B. Okay? Everyone understand? Okay, now try mode A, like this. M-O-D-E, open bracket, A, close bracket, like that. Okay, try that, what do you get? Numeric. Now try mode B. Okay, so it's telling us that the types of objects that are in the first vector are what? What types? Numbers, numeric, and the type in the second B is in what type? Character. Okay, so we can use this mode function to check things like that, and we will often. Okay, let's go on. What's this one? What's the point of this one? We did this before, but what's the point of it? This is a number. This is a, what did we call this? Logical or Boolean. It's called logical or Boolean. This is a what? Character, right? But when I do this, okay, let's check this one, by the way. Do this and call it C. C equals, and then do that. Okay, and then try mode C, and what do you get? Right, so, oops. Mode C, what do you get? Character, so what's the point of that? What's the point here? That even though you have, right, even though you have numbers, logical, and characters, it converts it to what? Character. Okay, in fact, I forgot to do this, but what about if I just type C? What do I get? Okay, they're all characters, right? So that's the point, is that if it has to convert, I mean, if it's a vector, what do we say? Everything in the vector has to be of the same type. So we can't, so if it has to convert, it's going to convert everything to a string. If there's one string in there, it's going to convert everything to a string. Okay, we did this already, 5, 9, what's that give us? 5 through 9. This one also gives us the same thing, 5 through 9. Okay, I'm going through old stuff, so I'm going through very quickly. What's this do though? It increments it not by 1, but by a half, right? Okay, so you need to know that. This one goes down. Okay, vector access. How can we access the elements in C? Okay, so try this. Type C square bracket 2. close square bracket. Type that, c square bracket 2. What do you think you're going to get? True. Why do you get that? Because you're accessing the second element in the vector. Okay, everyone understand that? Okay. How about this one? Sentence contains what? These three. If I do sentence 3, then what do I get? Blank, right? Why? Because we're accessing the third element in sentence, right? In the vector sentence, right? Okay, this is what? The first element. Now what does this do? Let's put sentence in R. So take this and put it in R. And then enter, and then try sentence. What do you get? You get the vector, right? What kind of vector is it? If I did mode sentence, what would I get? If I did mode sentence, what will I get? Did somebody say vector? I hope not. Character, right? Okay, it means that the elements are characters, right? Okay, now what is this going? So you have sentence in there. Now what is this doing? What's this doing? The third element of sentence was originally what? Third element of sentence is originally what? Blank, right? But when I do this, what's going to happen? Yeah, we can reassign the third element by doing that. Okay, now if I type sentence, what do I get? I don't get the same thing as before. I don't get walk the plank anymore. I get what? Walk the dog, right? Okay? Any questions about that? So what is the point of this? You can assign another element. You can reassign an element. Okay, here you can even do this. What's the point of this? We're going to have a bigger vector, right? Okay, everyone get it? Maybe let's add that to our workspace by doing that. Okay, now if I type sentence, what do I get? That. Okay, everyone get it? Any questions about this? Okay. Now, how do I access two elements in a vector? How do I access two elements in a vector? You might think you could do this. Let's try it, this. You might think that you could write like 2, 3. Let's write that. I want to get the second and third element. So you might think I could do this, 2, 3. Okay? I'm trying to get what? I'm trying to get 2 and 3, the and dog, right? I'm trying to get the and dog, right? The second and third elements. Let's see if this works. No, it doesn't work for some reason. How about this? If I remove the comma. Doesn't like that either. So how can I get the second and third elements in the vector, in sentence? How can I get it? This square bracket notation, if you're going to put something in there, it has to be a vector. Okay? So if you're going to put something in there, it has to be a vector. Now you might say, wait a second, you didn't put a vector in here. But this is treated as a vector, actually. It's converted to a vector with just one element. Okay? So what did I just say? If you want to access elements in sentence and you're using the square bracket notation, what kind of thing has to be in the square brackets? What kind of thing do you have to put in there? What's the proper syntax for the square brackets? It has to be a vector. And what does C13 create? What does this create? A vector, right? Remember, you could just take C13 like this. What does it give me? It's a vector, right? We did that already. It's a vector, right? So we're putting a vector into what? Into the square brackets. You have to put a vector into the square brackets, okay? Everyone get the rule? Okay, so if you do put a vector into the square brackets, then it will work, and what will it give me? It'll give me the first and third elements of that vector, right? In other words, if I do this, I'm going to get what? The first and third, so walk and dog, right? Let's see if it works. It worked, right? How about if you want to get the first and fourth element? How would you do that? What would I change here? I'd have to put a 4 here. Okay, is everyone following what I'm saying? So what's the rule here about the square brackets? You have to put in what kind of object inside it? A vector. Okay, everyone get it? Okay, so let's go on then. How about this? Will this work? Yeah, we already said that creates a vector. What does this create? 2, 3, 4. But the point is that this creates a vector 2, 3, 4. Okay, it's not just some commas, some 2, 3, 4. That's not what it does, right? It creates a vector. Okay, in fact, well, yeah, okay. Okay, so what's the point? What do you have to put inside the square brackets? A vector. Okay? All right, so if you do this, you're going to get this. Everyone follow so far? Okay, how about this one? Now what are we doing? What's this doing? First of all, is there a 5, 6th, and 7th element in sentence currently? No. So what are we doing? We're adding new elements. Again, though, what has to go in here? A vector. Okay, but now we're referencing new elements, in fact, elements that don't even exist yet, and we're doing what? We're giving them the values, the poop deck. So we check that, and it doesn't give us an error. Okay, everyone following so far? Just clear? Any questions? If I'm going too fast, let me know. No point in going too fast. So it's easy for me to go fast because I know what I'm doing. So you have to stop me if I'm going fast. But I don't want to go slower than I have to, because then more people will be bored. Some people are bored anyway, but more will be bored if I go too slow. So we have to do it at the best speed. Okay, so what's this going to do? Now you could get confused. You could say, wait a second, you just told me you have to put a vector in here. Right? But what's the argument for that, against that? Why does it take 6? Because 6, a number is a vector actually in R. Every number is actually a vector. We just think of a number as just a single number, but in terms of R, it's a vector. Okay, so we'll take a single number. Okay, everyone get it? Okay, vector names. For this challenge, we will make a 3-item vector for you and store it in the ranks variable. They use really strange examples here. I don't know. It's not very great. I don't get it. Anyway, they call it ranks, a variable called ranks. All right. You can assign names. Okay, you can assign names to a vector's elements by passing a second vector filled with names to the names assignment function, like this. Okay, first of all, what's the definition? Okay, let's create the vector called ranks in your space, in your workspace. Oh, you can't do that, you can't copy from here. You have to type it. Ranks 1 to 3. Okay, like you can do it like that if you want. Ranks 1 to 3. Okay? So ranks contains 1, 2, 3, right? As a vector. Okay, now, look what they do. Now, okay, everyone understand what ranks is? Right? Let's just make sure. Ranks. Yes? Check that. Okay, 1, 2, 3. All right, now, we're going to look at this statement. What is this doing? First of all, where is ranks in here? It's here, right? So it's inside what? It's inside another function. How do I know that this is a function? How do I know that this is a function? Because of the open brackets here, not the square brackets, right? Not the same thing, the square brackets and these brackets, right? These parentheses. Okay? So whenever you have parentheses, you're talking about a function. Do you see any other parentheses in the statement? Where? C, right? C is also a function. What's the name of this function again? The combine function, okay? But here, names is a function. So what are we putting into this function? Ranks, which we just defined here, right? Everyone understand? So what are we putting into names? Our vector, right? What does names do? It takes a vector and you can access the names of the elements. Now, currently, our vector doesn't have names. Our vector only has what? What is our vector at the moment? Now, if you type this, try this. Type names ranks. Let's see if it works. I think nothing will happen. Try that. What do I get? Null. What does that mean? There are no names associated with the elements. Okay, the elements are what in ranks? 1, 2, and 3. Okay, the numbers 1, 2, and 3, but there are no names associated with these elements. Okay? But if you want to give names to vector elements, you can do it if you want to. So how do you do it? You do it with a statement like this. So what are the names going to be after I do this statement? And if I retype names rank, what am I going to get? I'm going to get first, second, third, these characters. Okay, let's try this. Oh, can I do it? No. Can't copy this, can you? No. Have to type it. Okay, okay, try that. Type this statement here. And you're going to be giving ranks these names. Okay, did you get it? So now if you type if you type this now, you shouldn't get null. Right? You shouldn't get null because you just gave it some names. Is that clear? Okay. Now, okay. So they say assigning names for a vector can can act as useful labels for the data. So we can have labels for 1 through 3. Below you can see what our vector looks like. Okay, now, I guess I have to type it myself. Let me do it. I'm going to give it, I guess I'll do it. This is a really stupid example. Okay, let me explain why they're stupid examples. Look at the names 1, 2, 3. I'm sorry, look at the ranks. What is it? First of all, it's a silly name to call it ranks. It's just not a very great name. Second of all, what are the elements there? 1, 2, 3. And then what do they do? What do they give for the names? First, second, third. It's kind of like the student could be confused into thinking that somehow this has to be like related to this, and this has to be related to the second element. Well, it doesn't have to be like that, though. This could be anything, right? I could call this Tom, Jerry, and Tomoko, right? It doesn't matter, right? But this example makes it kind of confusing. It makes you think, oh, this has to be related to that somehow. Not good, okay? But anyway, that's the way they did it. What did I do wrong? What? Oh, thank you. Oh, right. Thank you. Okay, now, okay, so ranks looks like what? Let's try ranks. All right, now here's the confusing part. Somebody asked me this at the end of last class, and this is confusing. What does ranks contain? Some people might say, well, it contains this, and this, and this, and this, and this, and this. And that's kind of true, but it's not the best way to think about it. The way to think about it is ranks contains just the bottom row there. Just 1, 2, 3, just that vector. These are just names for the elements. Okay? So, when they do this, this just kind of violates this rule I said, which is that you have to have a vector in there. But anyway, ignore that for a minute. So when they do this, what are we getting? How can I access the first element of ranks? I said that one way to access it was this, right? Right? Remember I said that? Okay? What's this going to give me, by the way? Just going to give me the first element, which was what? Which was 1. Again, it's a stupid example, because the first element is 1. It's very confusing. Just not good. But anyway, okay? So I'm accessing the first element. Another way to access the first element is with its name. So what can I put in here? I think you have to use the full quotes. Okay, now what do I get? The same thing, right? So 2 ways you can access an element of a vector. What are the 2 ways you can access an element of a vector? What are the 2 ways that we know now? What are the 2 ways that you can access an element of a vector? What are they? What was the first one?
Numeric value, like the number.
Okay, we call it the index. Okay? So this one we say I'm accessing the first element. This is such a bad example. Let's create another vector. This is really a bad example. Let's try. Try that. V equals 3, 2, 9. Like that. Okay? Now, type out V, what do you get? 3, 2, 9. Okay, now give it, names for these elements, and let's call them Tom, John, and Mary. So give the names Tom, John, and Mary. Like that, right? Okay, now, how can I access the third element of V? So I could use the index for the third element, which means a 3. Right? So that would be what? V, square bracket, 3, close the bracket, and it's that, right? I access the third element, which is 9. What's the other way to access the third element? Use the name of the third element. What is the name of the third element? Mary. So what do? V, square bracket, Mary. Close the square bracket. Like that, right? What do I get? I get the same thing, okay? So what's the point? There are 2 ways now that we know to access elements of a vector. What are they? What's the right word there? Use the index, or what's the other way? Use the name. Okay, everyone get the idea now? Okay, so what are we doing here? We're using the name here, right? Unfortunately, the name is first, which makes it confusing, but okay. And that's done, I guess. Is that right? What am I supposed to do here? I'll type this in. Okay, we're going to follow this. Now let's continue. Now see if you can set the value for the third rank to something other than 3 using the name rather than the position. So let's do that with ours. So instead of V equal to 9, make it equal to 20. And don't use the index, use the name. So I want to change V, I want to change the 9 to a 20. How can I do it? How do I change the to a 20? V, what? V square bracket, then what? Huh? Wait, V square bracket what? 9. No. Okay, let's try that. V square bracket 9, he said. And then close the square bracket, right? Okay, let's just stop there and just see if we get any error here.
No, equal to 20.
No, but I mean, if we're going to write V9 like that, this by itself shouldn't give us an error. but it will. Why doesn't it, does everyone see what he said, suggesting? But if I type that, what do I get? Why does it give me some error? I'm looking for the 9th element of V, right? Right, when I type that, but there is no 9th element of V, right? If I type this, does that make sense? Is that going to give me NA? NA means not available. Okay, is that going to give me NA? No, why? Because now I'm looking for what? The 3rd element, which is available, right? It's 9. Okay, all right, now what's the goal? What are we trying to do here? We're trying to change the 3rd element of V from 9 to 20. How do I do it? There's 2 ways. There's 2 ways to reference that 9. What are they? Right, I could do this, that's referencing the 3rd element, which means I'm referencing the 9, and say equals what? 20, that should work, I think. Let's see if it works. Okay, now let me type V. Okay? Or if suppose I want to change it to 25, but I don't want to reference it with a 3, what's the alternative way to reference this element? Using the name, right? Which name? Mary, right? So I could do V, open bracket, no, not open bracket, there, and then what do I type? Quote, Mary, right? Close quote, right? And then close that, right? Okay, that's the other way to reference the 3rd element. Everyone get it? So what do I type? Type equals something else, right? Like equals, what did I say? So equals 30, for example. Okay? And now if I type V, what do I get? Yeah, the elements are what? 3, 2, and 30. Right? The names. So you should understand that the names are not really the vector. The vector is the elements. Okay, the names are just ways to reference the elements, okay? So if I multiply this vector, if I add this vector to something else, let's try that. Does that work? Let's try V plus 3. Okay? Okay, understand? So the names are just the labels. Okay, but the actual vector are those numbers there in this case. Okay, the names are not the vector. They're just ways to access the elements of the vector. Okay, does that make sense? Okay. So, let's see, what do I have to do here? Oh, I have to do that. Okay, so do this one here. Okay, any questions? Okay, plotting a vector. The barplot function draws a bar chart. So this function, called barplot, draws a bar chart with a vector's values. We'll make a new vector for you and store it in vessels sunk. Now try passing the vector to the barplot function. So here, they create, what is this doing? First line? What is that doing? Creating a vector, right? What kind of elements are in this vector? Are they characters, logical, or numeric? Numeric. Okay. Now what are we going to do next? This thing here, right? Let's try it for our example here. We also have a numeric vector, right? V. So why don't you try that? Bar plot V. Okay, what do you get? That. Okay, everyone get it? So bar plot makes what they call a bar plot graph. Right? Okay, now let's see what, let's try with nares. Bar plot vessel sunk. You do that, and you get that. What's the difference between theirs and ours? Obviously the heights are different. What else is different?
They don't have names.
They don't have names. Where do the names appear if they exist? Apparently at the bottom, right? Okay, because you can see in ours, we did have names and they appeared at the bottom. Now you can change the colors of these plots and so on. There are lots of things you can do, but right now we're not doing that. Okay, any questions? Now what do they do here? They're giving the elements of this vector, what? Names. Okay, so I'll just do that way. And hit enter. Now again, if we do bar plot, we're going to get the names at the bottom, right? Just like we had. Okay, everyone get this so far? Okay, how about this? What's this going to do? Before I do it, what's it going to do? Bar plot is taking a vector as an argument. Right? Is that true? How about the last time? When I did this, to create this, I used what function again? Bar plot. And what was the argument for that vector? It means what do you put inside that vector? I'm sorry, that function. What do you put inside that function? A vector, right? So bar plot is taking a vector as an argument, right? Everyone following me? Okay, so how about here? Is bar plot taking a vector as the argument? Is that a vector? 1 full colon 100? If you don't think so, try it here. 1 full colon 100. What do I get when I do that? That's a vector. Okay? So is bar plot taking a vector? Yeah. So what vector is it taking? This one. Right? So if I put that in here, what is it going to do? It's going to do that. Okay, everyone get it? Any question about that? Can we go on? Any questions? Okay. Most arithmetic operations, what do they mean by arithmetic operations? They mean plus, minus, times, division, and so on. Most arithmetic operations work just as well on vectors as they do on single numbers. Remember, we saw something like this. If we did 8 plus 9, that works, right? You can do that. They say you can also do similar things even if it's a vector. So if you add 1 to a vector, so here's A, 1, 2, 3. If you add 1 to it, you get that, right? So it works, so to speak. Okay? And the same thing with division. You can do that. Okay? And multiplying by 2. Okay, make sure you do that on your screen, so you can follow along. Okay, you can also multiply a vector times a number. All right? Any questions about that? If you add two vectors, R will take each value from each vector and add them. We'll make a second vector Okay, so here's B vector, and then if you do A plus B, what are you gonna get? A is what? A was 1, 2, 3, and B is 4, 5, 6. So if you add them, you get 5, 6, 7. Okay, everyone understand that addition? The first element gets added to the first element. The second element gets added to the second. The second elements get added, and the third elements get added, right? That clear? Now try subtracting B from A. So it works element by element. What did I do? I'm sorry, I made a mistake. B minus A. Huh? Striking outside, they want me to do A minus B. A minus B. Okay? A minus B. All right? Now, what's going on here? Next line. Right? Maybe, did we study that in class or not? I don't remember. Okay, anyway, what's going on here? That is not what I've been typing. I've been using the equal sign. This is not the equal sign, right? Obviously, it's different. It's a double equal sign, right? So it's has a different meaning. It's not assigning these numbers to A. It's not doing that. Okay? The double equal sign is asking a question, actually. It's not assigning anything. It's asking whether they're equal or not. Okay? It's not assigning, it's asking. Are they equal? Is A equal to that? I don't think so. A was what? 1, 2, 3, and that's different, right? So what's going to happen here? Are they equal or not? No, so it's going to say false. Okay? Everyone get it? Let's try it. What am I going to get here? No, they're not equal, so it's going to say false. If you're not, oh well. Okay? Oh, I'm sorry, wrong. Okay, I was wrong, I forgot. What does it say? True, false, true. What's the difference between what I said and this? These are element by element, right? Individually. Right, so the first element, I guess, was equal, right? 1 was equal to 1, 99 was not equal to 2, and 3 was equal to 3. Okay? Everyone get it? Sorry, that was wrong with me. Okay, notice that R didn't test whether the whole vectors were equal. It checked each value in the vector against the value at the same index on our new vector. Check if if each value in A is less than the corresponding value in another vector. Any idea how we could do that? So we didn't learn how to do it, but can we guess? So equals equals was for what? Are they equal? Why did they use equals equals? Why didn't they just use equals? Because equals has another meaning already. Okay? So they didn't use equals in that case. But in this case, we're not checking are they equal. I want to check is A less than B. Check. Is A less than B? Okay, B was what? B was this one, 4, 5, 6. And A was what? 1, 2, 3, right? So I wrote A, is A less than B? Any guesses what I might get here? What?
Oh, no, true. Yeah.
True, right? First, it's going to do it element by element, though. So it's going to test, is the first element of A less than the first element of B? Is that true? Is the second element of A less than the second element of B? Is that true? Third and third. So let's see. okay? It tests element by element. Let's try an ours here. Let's try, how about this one? Let's do this. What's this gonna do? Oops. Now, before you do it, let's think about it first. Before you do it, let's think about it. What's on the left side of the less than sign? What's on the left side of this sign? To the left of here, oh sorry. To the left of here, what do we have? A vector. How many elements are in that vector? 100 elements. What are they? 1 through 100, right? What's on the right side of that sign? A different vector, right? How many elements are in that vector? 100, and but it goes from it's descending order, right? From 100 down, right? Okay, so what's it going to look like? It's going to test it element by element. So what about the first one? It's true, right? But what about the last one? The last one. What's the last element on the left side? 100. What's the last element on the right side? 1. Is 100 less than 1? No. So what's it going to do? It's going to go true. What?
Half is false, and the middle one?
Yeah, right. So it's going to go true, 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 true. And then somewhere it's going to be false, 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 false. And where is it going to start for the false?
50.
At 50, right? Because 50 is not less than 50, right? So let's try it. Okay? Makes sense, right? Now how do I know where it actually changed? We just said, where does it change? From true to false, when does it change? At 50. So let's see something about this notation, the way it prints this. What are these numbers? These numbers are the first, the number of the element, I should say the index of the element, the first element in the row. So what's the index of the first element in the second row? 13. It means this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is the 13th element. This one is what? The 25th element. This one is what? The 37th element. This one is what? The 49th element. This one is what? Uh-oh. True? Wait. Wait. 50 is not less than 50. What's going on here?
If they're the same, I think it just says true.
No, I don't think so. Let's make sure of that. Try 50 less than 50. Let's see what happens. No. What's the first element? 1. What's the 49? Something's weird here. That's the 49, that's the 50th. I'm going down. 100. Okay, let me try this. Okay, here's something weird. Let's try this. Tell me if you can figure out what I'm doing here. Watch this. No, it doesn't want to do that. How do I do that? Okay, I have to do this. Okay, look what I did. And you can see why this one is true. What did I do? What did I do? What's this? That's the first vector, right? That was the left-hand vector, right? What did I call it here? A, right? Okay, now what am I doing here? What am I doing here? I'm extracting the 50th element from A. What is the 50th element in A? 50, right? Okay, now, what's this? What am I doing here? This is the vector on the right-hand side, right? B. B goes from 100 to 1, right? Okay, everyone follow? What am I doing here? I'm extracting the 50th element of B, right? What's the 50th element of B? We didn't count properly, right? The 50th element of B is 51. So when you count down, the 50th element is 51, right? So then, that's right? That's why we get true here. The 50th question was, or the 50th comparison was what? Is 50 less than 51? The answer is yes. Okay? Everyone follow? Any questions? Okay. Okay, let's see. Functions that normally work with scalars can also, oh, by the way, what's this function called here? The sine function, right? What's that look like? Looks like this. No. Yes. Looks like that. Okay? And what's this number? Do anybody remember? No. Pi. Because remember we're talking about an angle, and the sine is the y coordinate, right? So when you go, what's the y? This is 1, right? What's this angle? This is 45 degrees, right? I'm sorry, 90 degrees, right? If I go all the way around the circle, how many degrees are there? 360, right? That's also called 2 pi, right? When you go all around the circle, the length is 2 pi, right? So it's also called 2 pi, right? So if you only go halfway around the circle, how many degrees is that? 180, right? And what's half of 2 pi? Pi, right? So 180 degrees is what? Is pi, right? And then the sine gives you the y coordinate of this point, of the point, yeah. So here's a point, what's the y coordinate of that? 0. Here's a point, what's the y coordinate of that? 1. Here's a point, what's the y coordinate of that? 0, right? So the sine of this angle, what is this angle? This is 0. So the sine of 0 is 0 because it gives you the y coordinate. The sine of this is, well, I'm sorry, what angle is this? 95 degrees? So the sine of that is, I'm sorry, 90 degrees. So the sine of that is what? Is 1. The sine of 180 is 0. The sine of 180 degrees is 0. But another way to write 180 degrees, we said if you go all the way around, it's 2 pi. So if you only go halfway around, it's pi. So another way to write that is the sine of pi equals 0. Okay? You can write it either way. Sine of 180 degrees, or you can say the sine of pi because they both mean the same angle. Okay? So the sine, okay. So that's why I wrote the sine of 0. This is 0. This is pi over 2, right? If this whole thing is pi, then just up to here is pi over 2, right? So the sine of pi over 2 we said was 1. And then the sine of, this is pi, right? The sine of pi is that, okay? Anyway, we don't need that at all. We're not using this at all in our class, 0. But we just gave that example. And what they're saying is, you could put in the sine of 2 pi, if you want, or the sine of pi or whatever, but you can also put a vector in here, and it'll do it piece by piece. Okay, so what if I made a vector A, which was pi, comma, 2 pi, 2 pi. I think that's how we reference pi in R. You write pi. Let's make sure of that. Type in R, type pi. What do we get? We get that, right? So let's try this. No, can't do that. You have to make a vector, I think, first. Okay, what did I just do here? Last line there is what? P equals pi, comma, 2 pi, right? What did I do in, I created a vector, right? So what are the elements? Those 2 elements, right? Okay, now try sine of that. You ready? Didn't work, right? Well, it did work though, actually. Sort of. It worked, but not exactly the way we want it to work. Anyway, what should the answer be? The sine of pi and the sine of 2 pi. Where's pi? This is completely, we don't have to do this. I don't know, I should never have gotten into it. But anyway, I already started, so I may as well finish. So what's the sine of pi? 0. And what's the sine of 2 pi? 0. So we should get 0, 0. Okay? And we didn't get exactly 0, 0, right? That's because it did some calculations, and because computers can't deal with, computers are kind of limited in their calculation ability, so it doesn't actually come down to exactly 0. But these numbers are so tiny, they mean something like this. Approximately 1.2 times 10 to the minus 16. That's what that means, basically. So 10 to the minus 16th makes it almost 0, right? It's 10 to the, means like 1.2 times 1 over 10 to the 16th, right? If you multiply anything times the 1 over 10 to the 16th, you're basically making it 0, right? So that's what it gives you. But it's important to realize that it didn't actually give us 0. Okay, so could create an issue later on in some calculations. You have to be careful about things like that when you're working with computers. Okay? But basically it's 0. Anyway, we really didn't need to do that at all. Let's continue. Okay, so they did A, and they did that, okay. All right, let's try the square root. That's another function you can put a vector into. So go ahead and try that. Or if you want, okay. What do I need to type here? Open bracket, A, close bracket, right? Okay, like that. And it's going to give me the square root of what? What was A again? Here's A. 199 and 3. So when I do it, you get some numbers. Okay? I don't know, is that right? Okay, let's keep going. The plot function takes 2 vectors. Okay, let's try. Here's a vector. What's this doing? What does that do? It oh, sorry, what does it do? I forgot. What does this do? It's going to create a vector from 1 to 20, but it's going to increment by a tenth. So it's a big vector, right? There'll be a lot of elements in it. Let's just make sure. Let's try x and see how big it is. Okay, you see what it did? 1, I'm sorry, 1.0, 1.1, 1.2, 1.3, and so on, all the way up to, anyway. Okay, everyone get it? Let's just try that ourselves. Let's try sequence 1, 20, 0.1. Oh, by the way, one other thing, look. If I just type that, and I hit enter, it's going to say you didn't complete your sentence. Okay, watch this. Ready? Maybe just watch this because this might happen to you, so just so you recognize it. Ready? I'm going to hit enter now. I didn't finish typing, right? Forgot to close the bracket, right? That's what it does. It says keep typing. So now I'll keep typing by putting that there, and now it does it. Okay? So anyway, you see what it created, right? All right, so we have that in X. Does everyone understand? That's stored in X. Now they say, store the sine of X in Y. Now what's going into the sine function? What are we putting in the sine function? Is it a single number? No, what is it? It's all of these numbers, right? We're putting all of these in, right? So how many elements is Y going to contain? A lot, right? Let's try something here. Type this. What do you think this is going to give me? The number of elements in X. So, oops. I forgot to. I forgot to create X. Okay, there's X. Now let me try it again. Okay, what is this going to give me? The number of elements in X. There's 191 elements in X, right? Everyone understand that? Everyone get it? Now, how many, okay, now what's this doing? What am I putting into the sine function? How many elements? 191 elements, right? I'm putting in X, right? It's going to do it element by element. It's going to calculate the sine of each of them, okay? How many elements is Y going to have? 191, right? Everyone understand? Y is also going to have 191 elements. They're going to be the sines of each of these numbers, right? Okay, let's do that. Like that, right? Everyone understand? And let's try the length of Y. And what do you get? 191, right? That's what we said, right? We put in a vector of 191, we put it into the function, it's going to take the sine of each of them and create a new vector with that. In fact, if you want to see what those are, you can just type Y, right? You get these weird numbers, right? Okay, now we're going to do what? We're going to try a new function called plot. So try and do that here. Now, before you do it though, what was the name of the function, the graphing function that we used before? Barplot. And how many arguments did barplot have? How many arguments did bar plot, okay, that's a little confusing, but how many arguments does bar plot have? You could say 3, but that's not really what I mean. It's just a single vector, one vector. Remember what I said, how do you count arguments? You look for the commas. How many commas are there here? None. So how many arguments are there? What? Sorry?
It's only because it has a name now, though.
That's not what I want to say. Okay, so I want to say there's just one argument, okay? As compared to, the next example is here. Now, remember, vessel sunk was a vector, right? Right? In the last example, in that bar plot one, it was vessel sunk, right? And that was a vector, right? And you wanted to say there are 3 elements there, right? Let me show you again. Okay, here's vessel sunk, right? And you wanted to say there's 3 elements there. And I understand saying that there's 3 elements. But there's only one vector, right? Okay, one vector in there. Now look at this other function called, what's this new function called? Plot. How many arguments am I going to say there are here? 2. Each one of them is a vector. Right? Understand? All right, let's try it. What do you get? Let's plot this. Ready? 1, 2, 3, enter. Here it is. There. Okay? So let me just say it again. How many arguments does plot accept in this example? How many are there here? 2. And each one of them is a vector. Each one of them is a vector with how many elements in it? How many elements are in X? 191, and Y also 191. And then what we get is the graph of X versus Y. Okay, let's try another one. Let's try, no, we have to stop here. Okay, that's all for today.